device and able to conduct electricity almost as well as metal. For a few billionths of a second, the laser had recreated conditions inside Earth.
Say on
Now,
that?
let's get back to our journey. As our water
Nice.
starts to turn into ice 18, our
I
glob of
missed.
sodium is undergoing
Oh my
its
God.
own
I
transformation.
think my hands are a bit
Under
sweaty.
these pressures, scientists have seen it turn transparent. Now, what could account for this? Well, metals like sodium are shiny because they have a bunch of free-flowing electrons that can absorb and then retransmit light, which we see as a reflection.
What happens when you apply pressure to it is you're squeezing the electrons away from their atoms and into these localized pockets.
Trapped like that, the electrons can't interact with light, and so it just passes through. We've reached the center of the Earth, but that's not the end because we can continue into pressures found inside larger planets. Tens of thousands of kilometers below Jupiter's surface, physicists think hydrogen will go through another change, becoming a shiny conductor of electricity. It's thought that a lot of Jupiter is made up of this metallic hydrogen.
We think of high-energy density materials as completely inverting the periodic table. So your metals become transparent, and your transparent materials become metals, and all these gases become solids.
And the universe holds higher pressures still. The center of Jupiter sees over 10 million atmospheres, just about the highest pressure that the Omega laser can create. And now we're diving into the sun. The pressures rise over 100 billion atmospheres. The island of Manhattan balanced on a foam. We've seen extreme pressures overwhelm the forces that keep molecules apart. But here, within the sun, they can overcome the very glue that holds atoms together. Here, individual hydrogen nuclei can fuse to form helium, a process that releases energy. This is nuclear fusion, the ultimate source of all energy in our solar system, the reaction at the center of every twinkling star. If we could somehow recreate this process on Earth and keep it going, we would have a near limitless source of nuclear power. And researchers around the world are using giant lasers, including Omega, to study this possibility. This is all a relatively new frontier of physics. Scientists still have so many questions about the rules, about how different elements and substances act and interact under different conditions, and how that might influence the evolution of planets and their ability to foster life. They'll keep chipping away at those unknowns, one split-second experiment at a time.
Madagascar, an island off the coast of Africa. It's one of the most biologically diverse places in the world. Almost all of its plants and animals aren't found anywhere else on Earth. And when we looked at it from space, we saw a spot, a massive dark circle, almost perfectly round, over 13 kilometers in diameter, and big enough that roads are diverted on either side of it. Looking at it from the side, we could see it was a mountain, and if you zoomed all the way in, you could see a village. Nestled in the crater at its center, 8 kilometers from the closest labeled town on Google Maps,